Hello children, today's topic is atomic models. Democritus was the first person who said that atom exists. Atom is the building block of matter. Atom is very small in size and atom is surrounded by empty space. Atom is moving continuously through random. Dalton said that atom looks like a ball, billiard ball. Therefore his model is also known as billiard ball model. Thomson said atom looks like a watermelon, plum pudding. Okay, negative charge embedded in the sphere of positive charge. Rutherford said there is nucleus in the center of an atom which contains protons and neutrons. Electrons revolve around the nucleus in circular path. Bohr said atom has nucleus which contain neutron and proton. Electrons revolve in definite orbits which has fixed amount of energy. They will not lose or gain energy when they are moving in any orbit. When electron gains energy, it jumps to higher energy level. When it loses energy, it comes back to the ground energy, lower energy level. Finally, we have modern quantum cloud model, which says that atom is surrounded by electron cloud, where there is maximum probability of finding the electron. Okay, let's see this Thomson's model of an atom in detail. According to Thomson, atom is spherical in shape. Okay, it contains both positively charged particles and negatively charged particles, equal in magnitude, and therefore it is electrically neutral, equal in number. Same number of positive charge and negative charge particles, and therefore it's electrically neutral. Okay, its observation could be called as a plum pudding model or a watermelon. Let's see the video. Okay, plum pudding model. Thomson's model, also known as plum pudding model. You can see that raisins compared to electron and the edible part compared to positive charge. Watermelon seeds compared to electrons, red edible part compared to positive charge. Negative seeds, negative charge, red edible part, positive charge. Now, drawbacks of plum pudding model. According to this Thomson's model, plum pudding model, positive charge and negative charge, mass of electron and proton, they are evenly spread throughout the atom, which is wrong. Okay, which is wrong. From the Rutherford's finding, it came out that there is nucleus in the center of an atom, and mass of an atom is concentrated in the nucleus of the atom and not evenly spread throughout the atom. Next is the Rutherford's alpha scattering experiment. Rutherford conducted alpha scattering experiment and to discover nucleus inside an atom. Rutherford bombarded alpha particles doubly charged helium ions on a gold foil. He bombarded alpha particles on a gold foil and he made many observations. Based on that, he reached to the conclusion that atom has a nucleus. Nucleus contain proton and neutron. Okay, and the size of the nucleus is very small. It's very dense. Okay, let's see the video. radioactive substance producing alpha particles is a lead block. This is a lead block. Radioactive substance producing alpha particles, helium plus 2 ions, helium plus 2 ions. It's the gold foil, surrounded by ZNS screen, zinc sulfide screen. Alpha particle pass through the slit and strike the gold foil. Okay. So what he observed when alpha particles were bombarded on a gold foil, he observed that most of the alpha particles passed straight through the gold foil. There are gold atoms, gold foil, gold atoms are shown here. So most of the alpha particles passed straight through the gold foil. Secondly, he observed that some alpha particles showed some deflection, large deflection, small deflection, and very few turned back. Very few alpha particles turned back. What this proves, most of the alpha particle passed straight through the gold foil. That means there is large amount of empty space inside the atom. Large amount of empty space inside the atom. And some got deflected by passed straight through the gold foil. There are gold atoms, gold foil, gold atoms are shown here. So most of the alpha particles passed straight through the gold foil. Secondly, he observed that some alpha particles showed some deflection, large deflection, small deflection, and very few turned back. Very few alpha particles turned back. What this proves, most of the alpha particle passed straight through the gold foil. That means there is large amount of empty space inside the atom. Large amount of empty space inside the atom. And some got deflected by large angle, some by small angle. That means when positively charged body goes near to the positively charged body in the atom, it shows deflection. And that means, that proves that some positively charged body is present inside the atom. And very few got turned back. What this proves, that means the size of the positively charged body is very small in size. That's why very few turned back. Okay, so it led to the discovery of nucleus inside the atom. Okay, nucleus is positively charged body. It contains protons and neutrons. There is large amount of empty space inside the atom. Okay, and this is what was concluded from the Rutherford's experiment. Okay, most of the alpha particle went straight through the gold foil, were not deflected. Atom is almost empty. Few bounced directly back. This shows that atom is dense. It must be very small and positive. Several passed through the gold foil and were deflected. Nucleus must be positive. Law of repulsion. Okay, so this was about Rutherford's model. Drawback of Rutherford's nuclear model of atom. According to Maxwell's theory, any charged particle moving in circular path will lose energy. So, electron is also a charged particle. It is revolving around the nucleus. In circular path, it will lose energy and finally it will collapse into the nucleus. But this does not happen. So, atom is stable. So, Rutherford's model does not explain the stability of the atom, does not account for the stability of the atom. Planetary model of atom. Positive charge is concentrated in the center of the atom. Atom has zero net charge. Atom is electrically neutral, equal positive and negative charge. Electrons revolve around the nucleus like planets orbit around the sun. Okay, and Coulomb force plays a role of gravity. They are held by negative charge particle and positively charged particle are held by Coulombic forces of attraction. Coulombic forces of attraction. Next we come to Bohr's model. Okay, so Rutherford's model had one defect, so it was modified by Bohr. Bohr said that the atom has nucleus, right? It contains neutrons and protons. Electrons are present in fixed orbits. Fixed orbits, they have fixed amount of energy. Each orbit has fixed amount of energy. And when electron is revolving in any orbit, it will not lose or gain energy. Okay, so only when electron gains energy, it will jump to higher energy level, and when it loses energy, it goes to lower energy level. So this is the Bohr's model. Let's see the video. Let's see the video. Neil Bohr, 1915. Rutherford's model, that's the difference. That's it. Here fixed orbits are there. Nuclear model of an atom. This is the defect of Rutherford's model. Electron losing energy continuously. An electron is a charged particle. Continuously it's moving towards the nucleus and it's about to collapse. But this does not happen. So that's the drawback. That's the drawback. This does not happen. Okay, so that's the drawback. Okay, so according to Bohr's model, this is wrong. This is wrong. This is the Bohr's model. This is the right one. This is the right one. Electrons present in different orbits. They will not lose energy. Okay, when they are moving in a particular orbit. So this was about Bohr's model. Now let's see the defects of Bohr's atomic model. According to Bohr, the radiation results when an electron jumps from one energy orbit to another energy orbit, but he did not explain how this radiation occurs. Okay, electron jumps from one energy level to another energy level. The radiations are produced, and how these are produced is not explained by Bohr. Okay, children. So in the next video, I'll be taking the quantum model in detail. Till then, bye children.